So hello everyone. Today we will do a cluster analysis using Python. So the first thing I want you to open your Juoyter notebook. And as soon as it opens, I want you to open a new notebook. So we have opened the Jupyter notebook. And we're going to start with importing our NumPy library. So import NumPy as a PD, NP, sorry. And doesn't harm if you do basically importing a data set. So you can import pandas as a BD. But in this exercise, we will use already installed data set. Now we're gonna also bring from the sklearn library the cluster. So sklearn dot cluster. We're gonna import Kmeans with K and M as a capital letter. And we're gonna run now our programs. So after running our libraries, we're gonna starting set up our data. So data equals nb dot array, and you will starting opening a banana bracket. Then we're gonna add the first square bracket, then like the other one. So we're gonna add just any random numbers here, 1, 2, for instance. And before the second square bracket, we're gonna add another pairs of data sets. So 1, 4. But of course, you can add multi-dimensional data sets. So this is gonna be 1, 0, and 10, 2, and 10 and 4 with 10 and 0 and -1 with -5. Finally, 12 and -2. And after doing that, you should have another close square bracket and also another banana bracket. Then we have the data. So the number of clusters, for instance here, we will make it just 2. Now, cluster analysis is an unsupervised machine learning tool. So you can decide each cluster where they are belong to. You can do a content analysis or different things. So to know what are these features are sharing or what they are in common. So we have make the model. So K means equal K means. Now we can start adding the number of clusters. So n, which is the only the parameters this method needs. So equals k, and we can add also random state. So random states will equals to 1, 2, 3, because this is algorithm have an iterative nature. So sometimes you will get a different value, and we want to fit it over the data. Now, basically, we will need also to have the labels. So this is equals Kmeans dot cluster center. Sorry, Kmeans dot predict for data. And now we need to have the centroid. Okay, so center equals K means dot cluster underscore centers underscore. And we want to print both of these values. So print the labels, which is labels. And also we want to print the centroid. So the centroid will be equals to the centers. And you will run this short script. Okay. So we can see here, we have the labels here. So which is, so for the first pairs, we have 0, 0, 0, and for the fourth one, we have 1, 1, 1. And then like for before the last one, we have 0 and 1. Now you can see the centroids for each cluster are very distinct from each other. And if we can do a small visualization, that would be nice. So let's see how they look like in XYZ, since we have only two features. Of course, if you have more than three features, it will be very hard to plot all of them at the same time. So matplotlib dot py plot as a plt, and now we will start having the figure. So plt dot figure will be the fig size equals between 2 and 6. So this should be a banana bracket over here, and then we're gonna close it with another banana bracket. Now we're gonna add the scatter diagram for the two features. So plt dot scatter. Now in x-axis we will have the data for the first feature. So all of the first pairs 0. And this is how Python usually have the first value as a 0. Then we have the data. Sorry, should be square brackets. And now this is also another square bracket. Then we have 1 over here. Then we will basically color it with the red. So C equals, sorry, labels. Now CMap equals Verdes. And we will make them as also marker equals O. And we will have label equals data point. And close the banana brackets. And so I'm trying to figure out why these are not connected to each other. I mostly have messed up something. So PLT dot scatter, then we have the first feature, the second feature. Now C equals labels and CMap is Verdis. Okay, so we have forgetting this small issue here. Now we're gonna add basically the centroid. So scatter. Now how we have named it. So this is centers. So centers, this is gonna be a new matrix here, 0. And then we will have the other pair, which is 1. And again, so we have the same thing here. So C equals between citation reds. And we have marker. For the centroid, we will make it distinct from the point. So X, and then finally label, it will be centroids. And now we will have the plt.x label for x-axis, and this is going to be feature 1. And for the y label, so plt.y label will be feature 2. And finally, we can add some legends here. So plt.legend and open and close parentheses, and then finally plt.show, and I'll hopefully have run it without any issue. Oh yeah, centers. So centers, I forget to type in centers here. So I have a typo here. Figure size. Now we can see here. So the ones with I guess a blue color are belonging to the first cluster. This is their centroid. So the centroid is not one of the uh, basically data sets from here, and also applies to the second one here. So we have also another one. Now why we pick it number 2 as the number of clusters. So there is different ways to do that, but the most common way, so for each centroid or for each cluster, we're gonna calculate what's so-called the within a cluster sum of square. And basically, we try to do with that, and which one give us the least one will be the optimal number of clusters. Now, as we increase the number of clusters, so we will always having lower number of within cluster sum square. So the best thing is if we could basically draw an elbow curve, and when the rate is dropped very high, this is will be our best number of clusters. Now, if basically the rate of change in the within a cluster is kind of like a plateaued, or it is not that change much, then we can claim whenever the highest drop, this is our optimum. So we're going to create an empty matrix. So within a cluster sum of square, which is open and close and empty parentheses. Now we're gonna basically make the computer make number of clusters, and now we cannot make a number of clusters exceeds the number of elements here. So we have 1, 2, 3, 4, 5, 6, 7, 8. So the biggest number of the clusters will be 8. But for now, so let's say we're gonna do it up to 5, for example. I think we don't need to make it up to like what we have here. So for I in range between 1 up to 5, so we have the k-means. K-means will be equal. So our algorithm, since we already call it, so k-means, which is will be n cluster equals I. So every time we run this loop, we will have basically going from 1 up to 5. Now we're gonna have initial, which is equals k minus means plus, and then we will have the maximum number of iteration, because this is an iterative method, up to 300. You can make it more or less as you wish. And random state will be equals 1, 2, 3. Now we're gonna fit this model. So here k means dot fit into the data. Now we're gonna calculate the within a cluster and append. So within a cluster, sum of square dot append, which is k means dot inertia underscore. Now, after finishing this loop, so we can start plotting. So plot dot figure, and we have the fig size and 10 and 6 again. And we can also plot the number of clusters. So plot plt dot plot. We're gonna plot the range. So range is between 1 and 5. And in y-axis, we will have the win sum square. Now we're gonna add title, for example, title, which we forget in the previous one. So this is gonna be the elbow curve or elbow method as you mesh. And then PLT, no, this is X label. So this is gonna be the number of clusters, number of clusters. And finally, we have PLT dot Y label, which is gonna be the within cluster sum of square. And you can add also the PLT dot show, and hopefully in this time we're gonna run it without any errors. Maximum number, okay. K means any cluster. Okay, I think I forget S. Yeah, any clusters. Figure size equals. Okay, so we got it here. So from the data right now, you see like you have 2 elbows. And now let's see how is the difference between them. So this is was 75, and this is like reduce it to 50. So it's up to you to how the problem is sensitive. So you're gonna select the proper number. So I would go with 50 now, and then like it's just a plateaued afterward. Okay. So let's see here. It always end one before. This is what my mistake. So if I want to have, okay, so I think, okay, this is the number, cannot exceed that. Why? So maybe I will just keep it 3. And now we have, this is the optimal number of the cluster. Now, after assigning that, so let's go back here. And we have a 3. And see how it goes differently. Okay, this is the data point here. We're gonna run this again and see how it goes. Okay, so I think, yeah, so it's put only one data set in its own cluster and the other ones in 2 clusters. So I think the 2, let's see here in the figure, so 2 was better. Okay, so 2 was better because we have only one left. Okay, so thank you.